Assalamu alaikum, myself Anika Imran, registration number 21TE54. In lab number 3, what we have to do, we have to tell about the representation of the unit impulse, unit step, and the exponential signal. So first of all, it is the impulse sequence, and we generated our function, that is n1, n2, n0. So the main function is 0 to minus 5 and 5, and the range of this function is from minus 5 to 5, and we use subplot and stem function. When we run this section, this is our output, and if we have to shift our signal on the right side, then we have to add a variable in it like a here, and on this side with n0, what we have to do, we have to put a plus sign. And because why we added a plus sign, because we have to shift our signal to the positive side, and here we just added 5 and then run our system function. So we can see it can be shifted into the positive side. Now if we have to shift it to the negative side, we have to add a minus here, and when we run this function, now it will be shifted towards the negative side like this. So this is our lab task number 2, and in this one, this is about the step function. The first was the impulse sequence, and now it is the step sequence where we have used the function that is step, and n0, n1, and n2 is used. And in the main function, what we did, we have used a step sequence function and with the range of minus 5 to 5, and we have used the subplot and the stem function in this, and the x-axis is from minus 5, y is 15, then again negative x-axis and positive y-axis. When we run this function, this is our output. Again, if we have to shift it on the left side or the right side, we can do that. Here we are shifting our function towards the right side, so we are just adding a variable named s, and as we are going to shift our signal towards the right side, so here I am adding plus s, and in this one I'm just adding a variable that is 4, and then I will run my function. Now we can see it is shifted towards the right side, and again if we have to shift our function towards the negative side, we will just change our sign from positive to negative, and then we will run our function, so it will be shifted towards the negative side. Next is task number 3, in which what we have to do, it is about the unit step sequence by shifting the impulse sequence. So we have to construct the unit impulse sequence. Here the n is defined from minus 5 to 5, and the delta sequence is given, which is zeros and 1 and 5, and then 1 and zeros and 1 and 5. Then we have to construct our unit step sequence, where we have used the step command and zeros size and delta sequence, and then we have used the for loop, and what we have to do, we are generating our function. Then we have to plot the step response, for which we use the step function, and we have used the label that is x label, which is n, and y label, which is u of n, and title, that is unit step sequence. Then we run our function. This is our output, where unit step sequence is given. On y-axis we have u of n, and for x-axis we have n, and that is the required. The task number 4 is about the impulse sequence, where the delta n is the impulse sequence that is given to us. Then we have 3 given signals, x1, x2, x3, and we are doing convolution to these signals. So down here we have used y1, y2, y3, and convolution function is used, and delta n is same in all of these 3 signals. And after that, we are doing plotting of the figure, and we have used the command of subplot for plotting our signals, and the stem command, in which line width is 1.5. We have used the function of hold on, and again we used stamp and given the titles, and we have done subplotting 6 times. So every subplot will be different from the other, and at the end we used hold off command. And now if we run our function, we will see that we have 6 graph. For the 3 signals, we have 3 original signals and 3 that are convoluted signals. So All of you can see all of these signals are very different from each of each. Now the task number 5 is splitting the even and odd signal, for which we have used our function, that is xe, xo, and e for even, o for odd. And after that we have used a error function. So, and we have used a flip function and maximum and minimum function. If there is an error, so it will adjust the sequence, and then we are using the max and min functions, and then we are using the positive and negative functions down here. And basically they are used that if the signal will be on the right side, it will be positive, and if it is on the left side, it will be negative. And in this one we have used a function x, and it is from 1 to 5, and then we have used n, and we have used the subplot, that is 311. We have used three subplots. One is for the original signal, one is for the even part, and the next one it will be for the odd one. And same for that, we have used the stem functions, and the titles I have already tell you. So when we will, in the last task, task number 6, we need a continuous time signal in our output. So for that we have given the time from, that is from 0 to 2, and then we have given the frequency, that is 1. And here we use the continuous time signal, and we have given cos f 2 pi of t. Then we use the subplot and plot commands for plotting our signal, given the title, that is continuous time signal. On y label we have amplitude, on x label we have time in seconds. So now if we run our function, this is our output, that is a continuous time signal. And as given, we have given our title, that is continuous signal. We have our title here, and we have amplitude on y axis and time in seconds.